Howdy, this is Mr. Justice. I wanted to go through the rule of 70 and show you where 70 comes from, all right? So to do that, we're going to need to use the exponential growth model, and we're going to put some dummy numbers in, all right? So think about what the rule of 70 tells us. The rule of 70 tells us how long it takes for a population to double in size. Is that roughly equal to 70 divided by the rate without the decimal, without the percent sign, right? All right, so doubling time. Think about it, we're doubling the population. So let's just plug that information into this formula and see what we get. Solve for, well, RT. How about that, right? So take a look. Let's just pretend like we've got a population size of 1, e to the RT. Well, how long will it take t to go from a population of 1 to double to 2? Remember how to do this. We've got to take the natural log of e to the RT. And when we do that, natural log, we've got to do it to the other side as well. The natural log of e is 1. And if you remember what we talked about, the powers property allows us to bring the e's exponents to the front of the natural log. So take a look. Natural log of 2 is equal to RT. Times 1 times 1, but I don't need to put that on there because it's kind of implied, right? So take a look. So this is the interesting part. The natural log of 2, ready? I gotta make sure you see it. Natural log of 2, I'm gonna push the natural log button, ready? Almost 0.69, but 70 essentially, right? So think about this for a minute. 0.693, etc. is equal to RT. Well, if we wanted to see how long it took for that population to double in size, well, think about it. Let's get T by itself. T is equal to about 0.693 over R. The time it takes to double a population from 1 to 2, or from 200 to 400, or 1 million to 2 million is equal to 0.693 divided by R. Now you're wondering, well, that's not 70. If you remember, we've got to take the decimal point off of this. For example, if like how long does it take for a population size to double given a population growth rate of 5%? Think about this, right? I've told you before that you just take that 5% number and drop the percent sign, and you get 14 years, right? Well, what about if I was using this other equation over here, right? T is equal to 0.69 divided by R. The reason why it's 70 and not 69.3 is because we've already taken into account the movement of the decimal points for these rate numbers. Right, so let's do the same problem here, but with 5%, but I'll use the 0.693, right? So 0.693 over, well, I've got to convert this one to 0.05 is equal to the doubling time. Let's plug it into the calculator. I bet you it's about 14 years. Let's take a look. 0.693 divided by 0.05. And we get about 14 years. Right? I guess maybe the better name for the rule of 70 would be the rule of 69.3, but that doesn't just roll off the tongue. And so instead, we go with the rule of 70, which is a close approximation to what you would get if you actually plugged it into this equation here. I hope that made sense.